So now the oldest images that we have from antiquity and found on every continent is this image where 64 circles are overlapped. And it's called the flower of life. And on every continent it was found in whatever language, it was always called the flower of life. Mm-hmm. Well, 6,000 years ago, or however long ago, someone had the clever idea of saying, you know what, why don't I draw straight lines where the circles overlap? And play it from that point.
Yeah. So real quick, let me ask you. So this right here, what we're looking at is the flower of life, right?
This is the original flower that's carved into so many different places throughout the world. It's always been respected. And there's 64 separate circles.
And that's what the circles that we just saw being generated are literally how this image is created, by simply drawing 64 circles in this pattern.
Yep.
And I hope y'all are seeing how this is manifesting and how these symbols, and this is like a sand dollar almost.
Now, each one of these circles you have to see as a magnetic field. That's how magnetism behaves. Everything expands. But what they did 6,000 years ago, keep it playing, allow it to keep playing, is they began to average the space where the circles overlap. So that tetrahedron that we see, because we know that there are no straight lines, because all energy has an equal and opposite. Let's pause it for a second, just so I can repeat that. All energy is expressed in motion, all motion expressed in waves, and all waves are curved. Therefore, it is impossible to create a straight line, because every action has the equal and opposite reaction, and the greater that reaction, the greater the resistance, and the greater that curvature. This curvature is the equanimity of all the interactions within a particular system. It all balances out into these perfect spheres, which are magnetic fields around each other, which is a discharging aspect. And where these magnetic fields interact, this is where electricity begins. Where they overlap, they're forced to create spin. But 6,000 years ago, they said they're going to average the spin, and these toroidals happening, and they generated straight lines and approximated where the energy goes. So you can keep playing it. And now you can clearly see that even the cube, where we get Pythagorean theorem from, a squared plus b squared equals c squared, is an average. It's an approximation. But most of our math is our algebra, our calculus. All of those things are generated through this circumstance, which also led into why 1 times 1 could not possibly equal 1, because what if you made each side of those lengths 1? Then you couldn't get the proper hypotenuse. So all of these problems arose from them creating straight lines where there were no straight lines. And this has been called, the greatest discovery, basically, in geometry and for mathematics. But
and that's the Platonic solids you're speaking about.
The Platonic solids are averages. Euclid went to Egypt and pulled these things and wrote them down, and everyone took credit for them, but they took credit for some falsehoods. So they've watched it go through, and it'll go through the dodecahedron. So what I decided to do, what I was instructed to do, was to take the same flower. So can we go to my app?
Yep.
I think they've seen this already anyway, so they understand. So if we'll go to my app.
And that's the one where we can manipulate the
Yep. That's the web application. It's in my book, tclc.com. Going to page 134 on the right side of it, it'll say web application.
Okay, but it's the one that the second one, this one here, right?
Yeah.
Okay, let me move it.
This right here. This is what they'll find. Tap on it and we can start playing with it.
Okay, let's get this. So
it's very. Yep, there we go. And what he has there, there's an icon going from left to right, is what happens when 4 bubbles meet. I took actually the actual curved triangular pieces, and I put 4 of them together based on universal ratios. And this is what it generated. We bring that closer so everybody can. and look at it from not just the top, but from maybe a 60-degree perspective, a little more and closer, just so they can see it. What you're looking at right here, if you'll rotate it, this is the point where bubbles meet. This is the negative space that they cannot compress. This is what we would call dark matter. This is the proton, the geometry of hydrogen itself. And we'll see that it has 8 poles. It has 4 contractive poles, and that's where it concaves in, and it has electricity seeking a higher pressure condition will cause a cavity, and magnetism, unable to maintain its electrical potential, ends up spinning off of the vortices.
So real quick, brother, when you say 4 bubbles, you're literally saying that there's a sphere here in this space, and this is just the negative space when 4 spheres are literally coming together. This is the space that's left in between them.
Yes. Yes.
Brilliant, 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 brilliant. You know, because I know people say bubbles. 4 bubbles, what are you talking about? Uh-oh, sorry.
Go ahead.
You know, and that's what people.
Go ahead.
Okay, I'm sorry. Just real quick. People are trying to understand when you say bubbles, you're literally talking about 4 spheres. And like you said, you can see this concave. It's like you could put a sphere here, you could put a sphere here, one on the other side, and then one beneath. And this is the this is the actual shape that you're going to get. And one thing really quickly, and then I'll shut up. But one thing when I was looking at this earlier, I literally see I see 3 circles on the ground here. You got this circle here. I don't know if you can see my pointer. Circle here, a circle here, and a circle here. These are 3 of the bubbles, 3 of the spheres right there. And you put another one underneath it and you got your 4.
And that's what the flower of life was trying to leave and tell us, 10,000 years ago, by whomever advanced civilization told us that these would be the fundamentals, because everything expands as a sphere and contracts in geometric form. These contractions are the result of expanding waves that hit the edge of the universe and come back. And it's periodic and regular enough to where we have this structure that we call hydrogen, the proton.
And when you say periodic, that's the periodic part, right? It's just in intervals, predictable intervals.
Yes.
Nice. Should I go to the next one?
Yeah, go to the next one. The one next to it was, and I called this one a tetryon. And the next one, and I patented these things because I wanted to make sure that it was understood where they came from. Because a lot of times our work is not attributed to us.
Right, but like George Washington Carver, he didn't want the patents for his stuff.
Yep. So like that last one that we saw, it had 4 equal contractive poles with 4 repulsive poles. 4 electric poles, and contractive electric poles, centripetal electric poles, and 4 magnetic centrifugal. Now, this is what happens when 8 bubbles meet. This is the negative space where 8 bubbles have met. But you'll notice it has 8 contractive poles. If you spin that around, you see 1, 2, 3, 4. And around it, you'll see the same. You can go slightly underneath it. Yeah, you'll see the other 1, 2, 3, 4. Sorry, you do that. But yeah, just spinning it around it. Just continue turning it to the left. Yep. You'll see that there's 4 poles there, 4 contractive poles. So there's 8 contractive poles, electric poles, but only 6 magnetic poles. Only 6 points where it's discharging. Now, wouldn't that sound like the strong nuclear force in comparison to the weak nuclear force of where it's an equal and it's 4 equal contractive poles and 4 equal repulsive poles? Well,
when you talk about the 6, you're talking about these 6 points here, right? 1, 2, 3, 4, 5.
Yep, each vortice is 6. A magnetic pole. It's a discharging pole. It has a greater electrical potential, a greater electrical and attractive potential than a repulsive potential. Well, let's see what happens when 6 bubbles meet. If you go to the very next one, right? Yep, right there. Wow, look at what's happened. This thing has now this hunting, which is in the center, has attracted these 2 lesser attractive components. This looks just like a photon, and you could see those big swipes where 6 bubbles or 6 fast moving bubbles are occurring. 1, 2, 3, and keep turning it, and you'll get all 6 of them. Each of those huge, and you'll see it's a combination, and this is a step up transformer. You're stepping up from 3 sides, 1, 2, 3 from these, from the tetraons that's on the ends of it. You're stepping up from 1, 2, 3 up to a 1, 2, 3, 4 on electrical potential with the Huntian, and then it steps back down to a 1, 2, 3. Well, that's everything that we see with our mechanical and our electrical transformers, a step up and step down transformation. But wow, the stable structure. So let's see what happens when 12 bubbles.
Okay, so real quick, you said with our transformers, you're literally talking about the electrical transformers that are on the power lines, stepping up and stepping down energy.
Yes, a step up and step down transformation. Everything behaves that way. So here's the, I say is here is the strong and weak nuclear forces. And now this is what happens when 12 bubbles meet. And what this ties into is what we were saying under different motion and pressure conditions. You get a different crystallization. Here's another stable structure, but it still has 4 electrical potentials that hasn't been accounted for in the Huntian. Still has 4 unaccounted for. The points at, if you go to the center, point your pointer to the center, rotate it to the right a bit. If you rotate it to the right and zoom in a little bit, yep, and zoom in and take that pointer right to that center point, to the center, yep, there. That's the unaccounted electrical potential, and it has 4 of them. So this thing still is attracting things, but it's a stable structure. And then, so you go to the very last one. If you, so you can see, and I didn't have to break any rules to make that.
Right.
And
so you're constructing these. You're constructing these on solid mathematical principles.
Universal ratios.
Wow.
So now you look at, now this Huntian, all of its electrical potential has been accounted for. So you would not be able to distinguish this from the background, from the rest of the universal background, because it gives off no electrical potential.
Wow.
And so this is the Bose-Einstein condensate when something becomes indistinguishable from the fabric of the universe. This is that.
So Terrence, somebody who's a mathematician, a physicist, electrical engineer, chemical engineer, seeing this, their mind should be getting blown right now, right?
Yeah, or they should get turned on. And I look forward. I'm at the point now where I'm ready to war. So I challenge any chemist, any physicist, any astrophysicist, any cosmologist, any biologist, anyone within the fields of science to come and challenge me. And these are proofs. This isn't theories anymore. Theories are written out and need to be proven. These are geometric proofs.
Right.
These are
this is proof of concept right here.
And what you're looking at is electricity. These are the natural folds of electricity. Now, they have other supplemental folds that ends up occurring, but this is the highest point of contraction where everything is held in and there's balance. Now, I want to show the supersymmetry of these with that other video that I sent you of the structure I've actually made by hand. This is what I've sculpted.
Okay, here we go. So it's the with the clear plastic pieces.
Yes.
Okay. Here we go. Let me see. Yeah. Yeah. For those who are watch and rewatch, and pull in some of your chemist friends, some of your biologist friends, physicists, and we want you all to approach in good faith. Don't come with no trickery and no slick stuff. Come in good with the purpose.
Uncover everything that they're doing. Everything that they're doing. You could come with all the games you got.
But we don't want it. Just come in good faith. I know. See, that's what I was saying in our last conversation. You want
their degree.
I got you.
I want people to put up their degree. If you're going to challenge me, and I will put my patent up. And if you come and show me a better model of the universal constant of become yours. But if you cannot, your designation as doctor comes to me in whatever field you have. And I put that up one there. Anybody that has the ability to match me, you have no right to challenge what I have to say. And you are going to do it,
Brother Terrence,
in good faith.
So I think that the computer is glitching right now for a reason, because literally it was just glitching. And so it's that warrior in the garden type of thing I talked about last time, right? It's that, you know, we would rather be warriors in the garden than gardeners in the war. Uh-oh. Yeah, see, we lost him. He something happened with the connection on that end, but I'm sure he'll be right back in. But that's what I was saying, though. It's like the warrior energy and the warrior spirit. It's like, that's what I'm saying. Come in good faith. When you see that what this brother is putting forward, for all my scientists out here that are watching, and people who have friends that are scientists, that are chemists, that are physicists, that are engineers, you know, share this video with them. Share the concepts that Brother Terrence is putting forward, and come in good faith. Come not to battle. Come, you know, don't come to try to trick and to deceive and all that type of stuff. Leave all of that out. Do it for the sake of science. Do it for the sake of us being able to, you know, explore this truth for what it is, right? Because that's what's necessary. We need to continue to build forward. We need to continue to, you know, to correct things that have been incorrect for so long. And it can only benefit everybody. The only thing that's going to be injured potentially is the ego that tries to stand in the face of truth and maintain falsehood and deception. And so, Brother Terrence, what I was saying while we were waiting on you to come back in, and that's, you see the energy, you were ready to fight and it glitched, just totally glitched out. We couldn't hardly even hear you anymore. And that's what I'm saying. It's like, let's invite people in good faith, right? You're still muted, brother. Let's invite people in good faith. We don't want to fight. It's not necessary, but it's possible. And you're ready for war if that's what you want.
Well, but an argument isn't necessarily violence. An argument, people expressing their passionate views towards truth. I like that. I appreciate that.
It's fine.
You need to throw insults in order to make your point, you know, but you still, at the end of the day, it's going to come down to facts. And see, with these, I didn't have to do any renormalization. I didn't have to erase or discontinue or try and subtract out inconvenient values that showed up. I didn't have to trim any parts of this out to put these together like they have done with their math.
Right. And so the approach that I'm suggesting is kind of what I do with if I got some students going to present their dissertation, and I feel unnecessarily call it the dissertation defense. And what that does is it sets them up to approach it defensively. And so what I do is I reframe it and I say, nope, you're not coming to defend anything. You're coming to present it. And they sit back and say, dang, I never thought about it like that. I said, nope, you're coming to present the work that you have done. You're not defending anything. You're presenting it. And that's going to keep you open, and it's going to keep your committee open. So that way it facilitates the conversation and the communication, and it allows us to get to that moment of truth quicker with less bruises, right? But again, it's like you say, Jordan Peterson said it, you know, we've got to stay dangerous. So if a person don't know, and that's the real definition of meek also, is somebody who has the swords, who's capable of carnage, fully capable of it, but they keep their sword sheathed. Yeah. I'm not going to even draw down on you. Matter of fact, I'm coming in such a way that you won't even provoke that. So and that's just all I'm trying to do, because what I am fully invested in is us moving this to where we are on the largest stage possible, presenting these truths to where the highest levels of academia are saying, wow, Brother Terrence, Deshaun Howard, we apologize, you know, for all of those times that we have basically shitted on you and your name. We apologize for not being receptive the first time you came around. But now we hear you clearly, brother. Let's make this work. That's the day I'm looking forward to, and I want that to come sooner than later.
So too. But in interim, I'm looking forward to, because they have bashed my name so much, it is necessary to defend it. So now I'm saying there's consequences. So if you're going to come up against my name and come up against these things, then let's do it on a public forum.
Yes.
And you debate your position and I'll debate my position, and we'll let the public decide. And
Yes.
if you like it that way, we can go and have a private conversation, because I don't want to destroy anybody's faith or humiliate someone in front of others. But
Right.
if you like to have a private conversation, we can do it private. But if you're going to make public statements, then we're going to have this on a public forum. But I come peace, even though the things that I bring, may rattle the establishment, and the established standards, but that's how we grow. We don't stay soil as seeds. We sprout up and begin to grow, and we challenge the upper atmosphere, and we challenge the sun and how long we can stand in it, and we challenge the earth and sticking our roots deeper and pulling its sources. We have to keep growing, and growing, it takes some breaking. So I don't mind. I don't mind presenting and talking to anyone that has something to talk about.
Right. And as your brother in arms, brother, I'm just saying, y'all come in good faith. We'll get further quicker that way. But if
that's at Morgan, we came in really good faith.
You want to fight, as you all see my brother. Yeah, and we
can debate. We can debate about anything.
Let's show the video.
These are the sculptures that I created.
Yes, and so this brother is sitting and literally putting these shapes together by hand. Can you see the screen?
Well, that's the wrong one. You're actually about to do the magnetic field. I don't want to show the magnetic field just yet. Okay. I want you to do the video where it's all of the crystal.
It starts from the top.
Yes.
I got you. Yep.
And that's to demonstrate the supersymmetry of what I just showed them in the web application. This is the supersymmetry of them all working together. You might have to start it again. Weird. That is so.
I got to figure out how to zoom this in, but I got you. Here it is. Okay, yeah, it won't allow me to zoom it in. There it is. Can you see it?
Yeah, can you start it over?
Yep.
Now, all of these are different motion and pressure conditions. We have Abrians, we have Adrians, where five of them have come together. Five of these Aubrian pieces have come together. This is 10 of them coming together, and they predict every potential wave that can ever occur. And these are multiple different wave conjugations or pressure conditions, but you see how they all fit together. Here we are back to the Dacian, where 6 bubbles meet, blending in with what happens when 12 bubbles meet. Here's 5 of the Dacians come together. Here again, which are the light units. All of these things are different motion and pressure conditions, but it shows you when 2 or more of them bond or come together, it creates a natural waveform.
Wow.
These are the true, this is the structure of electricity. This is the dark matter that they keep looking for. It's already been found. It's already been patented. And I look forward to us now developing new postulates and new axioms based upon these real true curved spaces.
And so so you've also talked about being able to predict the entire Milky Way, and that was in a simulator. Right. And so you were able to use these same patterns and explain for us in basic terms what you meant when you said you were able to map the Milky Way. Like, talk to us like you're talking to a 6th grader.
Well, what we did is, instead of, they always say gravity was the cause of, planets and anything coming together. And I disagree with that. Nature disagrees with that, because it is electricity that's 137 times more attractive than the effects of proposed gravity. And as a result of that, and that's an interesting number, because if you think 1 over 137, that's the fine structure constant that's responsible for everything in there. But it should tell you about the relationship of electricity. But as far as being we use linchpins to predict we can use the wave conjugations, but we use linchpins by putting them in the apex of our solar system. And along the galactic plane, you'll see the leg of the linchpin able to predict every single star on the galactic, the celestial, and the elliptic plane. Each one of, like if you picture an atom, the average picture of an atom, you'll see a circle, and you'll see something this way, another circle going this way, and another one going this way. That's the elliptic, the galactic, and the celestial plane.
And so you're saying that at certain points on the linchpin, there are going to be stars that are going to be on these points. At
every single carbon line, which is the center line of struts of the linchpin, you will see the other stars that accompany them. And the noble gases that's holding those together are on the edges of that pentagonal strut. So you're now able to predict all distribution of matter, all distribution of motion. And then you use the wave conjugations to fine tune, because every occurrence of matter happens as a result of a harmonic, sympathetic, vibratory relationship.
And that makes sense, because you're saying that the linchpin design is based upon the geometry of a proton.
Of the tetrahedron, yes.
And that means that everything that is a thing should have this same basic pattern. I think you talked about it being like fractal.
Yeah, the grand unified field equation is the fractal.